I'll be presenting work. So I'm Joe Osborn. I'm at Pomona College. This is work done by my undergrad RAs, Cynthia Lee and Katiana Wieser. And we're here to talk about this weird little project called Asterism. Here's an overview of the talk. We like to think of games as being like expressions from the language, if you like, provided by an engine. There's some connection here to like shallow embedded DSLs or something, but I think that the hinge here is that making game engines is productive in that you can make a lot of new games if you have a game engine, but it's also difficult. Moreover, in this particular community, we're really interested in questions like design verification or visualizations of game state spaces or whatever. And it's a pain to have to do that fresh for every new game engine you might want to come up with, or every new game. So we're looking to do something that is allows us to multiply our effort a little bit, and we're hoping that modular game engines will give us a lever that we can use to reuse this kind of effort across lots of different games, lots of different game engines. We think that the way of doing this is using game studies formalism called operational logics, and I'll conclude with sort of next steps, or now that we have Asterism, what can we do with it, or what can you do with it to follow through? So we really like game engines. We especially like specialized game engines. So if you have something like PuzzleScript or Bitsy or Mosey or Twine, you have a very powerful tool that's powerful because of its specificity. You can present an interface that is very usable, that doesn't force people to take a lot of extra steps or do things that are not relevant to their design. But coming up with new tools like these is difficult, not only from a sort of programming standpoint, but also from an interface design standpoint. And it's a pain that we have to, like, if I wanted to make an automatic game player for PuzzleScript games, I couldn't turn around and use the same thing for Bitsy games, even though many PuzzleScript games and many Bitsy games have very similar structures, like a avatar moving around a space, in discrete steps or something like that. It would be great if we had some like shared models of interactivity or interactive systems. Even in the cases where you have game engines that have something in common, some metaphor in common maybe, like Unreal and Unity and Godot, all have these like game objects that you can attach behaviors to. They're in some kind of scene graph. But it's hard to imagine writing one tool that would work across all three of those engines, even though those engines have some kind of similar ontology. We don't have any kind of shared abstract data type or shared protocol across these three types of engines. So the move that we're making in Asterism is to say, well, we have operational logics, this idea from game studies that has been around since Noah introduced it in 2005. I've had really good luck with this, with Adam Somerville and others, for the problem of design recovery. So can we represent game design information in a way that that is amenable to like machine learning or heuristic techniques to pull design information out of a running program? And I've also had some success with it on the DSL side. So I did a project a while back where action game characters are represented as hybrid automata. So it's a very fruitful, like productive metaphor for how games work and what games are made of. Operational logic, they are not mathematical logics. They are sort of interaction logics. I'm sorry, that's just the term it is. It wasn't my term, but I guess I'm continuing to use it anyway. An operational logic combines some abstract process like resource transactions or collision detection with a strategy for communicating that process to players. So a resource logic might involve numbers and icons representing how many of each type of resource you have. A collision logic might present itself using shapes on a plane. And we can build concepts, game-specific concepts, or even engine-level concepts, out of combinations of terms from these logics. So something like a maze or a level might just be a collision shape. And you see this in like a mesh collider in Unity or something, right? Like you can have a meaningful game object which is just a collision shape. A character, on the other hand, needs more than just a collision shape. It's the collision shape, physics state, their health resource maybe, and some kind of state machine governing their behavior. And these are, if it's a player character, you might also have like a control scheme, right? And we can make as many characters as we want, and we know that if it's a character, it has these four things. They're tied together, they share the same identity. Once we have these concepts, and we have our logics, which provide certain operations like are two things touching, or change the collision flags on this thing, or increase this resource by this amount, we can start to build game mechanics. For example, when a player character touches a monster character, reduce the player's health by 1. The template, if you like, for many, many different mechanics. There have already been, for example, successful game mechanic generation or game generation approaches that use templates like this. Alex Zook had a paper doing this in answer set programming, and the Gemini project also generated games using this kind of scheme. Starting from operational logics, we operationalize them, sorry for the pun, into a concrete program, a Rust library for making game engines that we call Asterism. The Asterism code defines some type classes or traits in Rust parlance, which describe operational logics. So each one can define some concepts, which can be combined together into like new game objects, and also operators that can be combined together to produce game mechanics. We also define a set of concrete types, which define a means for operational logics to communicate, a sort of blackboard, although it's not based on, it's based on the technique from the data-oriented programming discipline called existence-based processing. It's a sort of iterator stream kind of situation where data can flow and be processed through different stages. It's pretty generic, and for us, what's attractive about it is it means that we don't have to say iterate over every pair of objects and test if they are colliding, or even iterate over every object and see what it's colliding with. We can just say respond to a stream of collision events and handle them that way. Both approaches are possible for game engines written in Asterism. Both are available. We also provide example implementations of some particular operational logics, the ones listed here. And finally, we give 2 example game engines that are built from these components. One is for Pong-like games, or maybe Atari 2600 style games, and the other is for Bitsy-like move around and bump into things games. The workflow with Asterism, if you want to make a new engine, is or a new game, is to select some operational logics that you want to use or implement some new ones, as long as they conform to the traits that are defined in the Asterism library. They will work. They're on the same kind of status as any other operational logic. You define new archetypes for your game objects using terms from those logics. So there's some similarity here to something like entity component systems, but that's like a kind of low-level pattern, and this is more of a ontological commitment, I guess. Next, using these concepts that you've defined, we can also introduce game mechanics, graphical affordances for display. For example, again, for mechanics, an event happening in one logic may be provided that some query is true of another logic, means that some reaction of yet a third logic can take place. Right now, implementers of game engines also need to implement their game loop. If we think that this is an important point of flexibility, because you can structure game engines in different ways. And then optionally, your game engine can provide macros or code generation techniques or shallow DSLs or whatever to make it easier for designers to implement games in your engine. Here are a few Pong-like games. Like what typifies a Pong-like game for us is, you have like paddles that are controlled by players, you have walls that are inert, and you have balls that move around and somehow react with stuff in either the paddles or the walls or other balls. So we have our cat herding game, Clouder. We have apple catching, which is a kaboom-like, where you need to move a basket to catch some apples, and we have sort of classic Pong here on the bottom. And all of these games share these 4 operational logics: collision, physics, resource, and control. We construct concepts like paddles, balls, and scores, and allow designers to implement mechanics of the form when X touches Y, do Z. Filter some events according to some criteria, and then trigger some reaction. Here's an example of our little DSL for paddles, which is the name of our Pong-like engine. This is the fundamental rule of Pong. Bouncing means we filter collision events. So look at all the collision events, all the collisions that transpired. Make sure that they are between a ball and either a wall or a paddle. That's what this closure here is doing with some ceremony. It's straightforward to imagine specializing the DSL more for this kind of case of checking like consistent pairs of collision flags. But this is the way it is. And finally, for each of these bounces, for each of the filtered bounce events, we trigger a bounce ball reaction for that particular contact. And the bounce ball reaction looks at the normal of the collision, figures out like which side of the ball was touched by the wall or whatever, finds the physics state corresponding to this ball, and inverts either its y velocity or its x velocity, and then stores the new physics state into the physics logic here. So that's like the basics of Pong, right? If you have that, you pretty much have Pong. Our code is all available on GitHub. I'm happy to share it. There's a link in the paper that you can see if you're curious about the complete implementations of these games. Boxy is our second engine. It features linked rooms and a linking logic, discrete tile-based collision. So this doesn't use our built-in collision logic. This uses a fresh one implemented just for Boxy. That has some similarities to the standard collision logic, but is much simpler and doesn't because each tile. The only rule of this collision logic is no 2 objects can inhabit the same tile. And then there's also a control logic for mapping onto player movements, and a resource logic for tracking inventory and other kinds of items. Boxy defines a shallow DSL with just like an API, if you like, where maps can be defined as puzzle script style grids of numbers. The world is made up of rooms. Rooms have links between each other, and we can also create resource pools that are then, maybe modified when player touches something or has some conversation with somebody. Our current work on Asterism is focused on making more games and engines, adding more logics, coming up with a more Asterism, like moving more of the graphical and audio-visual kind of communication stuff into Asterism rather than leaving it mainly up to the engines, because we think we can get a lot of leverage off of operational logics here. And giving some facilities to support richer domain-specific languages. We're also looking at coming up with design support tools that cash out on our promise of, building it for one logic and having it work in every game that uses that logic, or every engine that uses that logic. And we're also interested in things like accessibility support. So if we know at an engine level, or even at like a meta engine level, what things are and how they're presented to players, we can also present things differently for different players. So defining new engines is straightforward. Defining new games is easier if you have specialized engines. And this opens up the possibility of tool reuse. So we hope that you all will come up with weird new game engines. We're happy to talk about the technical details or help people get started on this. And that's our talk. Thanks very much.